Okay, this is Study Island topic, scientific notation. Number one, a day is equivalent to 8.64 times 10 to the fourth power seconds. What is this time in standard form? So scientific notation is what it gave you. It gave you the number of seconds in scientific notation. Scientific notation is always a single digit from 1 to 9, so 0 doesn't count, then a decimal point, then some other digits. In this case, it's 6 and 4. And then it always says times 10 to an exponent. And in this case, the exponent is 4. Let's review about what exponents are. Exponents are how many times you're multiplying something. So if I was going to write this differently, it might be 8.64 times 10 times 10 times 10 times 10. 10 to the fourth power would be times 10 4 different times. Well, you should know that every time that you multiply by 10, all you have to do is move a decimal over one place. So you're going to end up moving a total of 4 decimals. So let's go ahead and break this down. If we have 8.64 times 10 times 10 times 10 times 10, hopefully you realize that the shortcut when you multiply something by 10 is you simply have to move the decimal point over. So let's just do the first part. 8.64 times 10 would be 86.4. So then we'd only have to do it times 10 3 times. So we had 86.4 because we did 8.64 times 10. That's these two. Well, then I'm going to do it again. 86.4 times 10. I move the decimal place over one spot. So it's 864. And then we have times 10 and times 10. We have 2 more 10s left because we just did these two. So we have 864. And then times 10 again. Now we're out of decimal places. We have to start adding zeros. So 864 times 10 is 8,640. So we have that times 10. And 8,640 times 10 is 86,400. So if we relate this back to our original scientific notation, we have 8.64 times 10 to the fourth power. We simply take our 8.64 and move our decimal 4 places. 1, 2, 3, 4. It's right here now. Everywhere there was a blank spot, we put in a 0 as a space filler. And so it's 86400, then the decimal point, and there's an invisible 0 after it. So it's 86400.0, which is just 86,400. That's what it is in standard notation. Standard is just like the regular way we write numbers. So that's our answer, 86,400, and it's C. Our next one, according to the Bohr model, the radius of a hydrogen atom is approximately 5.29 times 10 to the negative 11th meters. What is this measurement written in standard form? So we just did one thing, going from scientific notation to standard form, and it was simple. We just multiplied by 10 every time that it told us to. So we just moved our decimal that many places. But this one's a negative exponent. What do negative exponents do? Well, if positive exponents are multiplying by 10, then the negative exponents are going to be dividing by 10. So this is the way you should think about this problem. 5.29 times 10 to the negative 11th power is the same as saying 5.29 times whatever 1 divided by 10 divided by 10 divided by 10. 11 different times I'm going to do this. We divided by 10 once, twice, 3 times. I'm going to divide by 10 again. I'm going to divide by 10 again. I'm going to divide by 10 again. I'm going to divide by 10 11 times. Now that's ridiculous to write out. So I'm not going to write it out that many times. I'm going to write it a little bit easier. I'm going to say 5.29 times, well, hey, if I have 1 divided by 10, isn't that 1/10? So if dividing by 10 is the same as multiplying by a tenth, then I could do times 1/10 times 1/10 times 1/10 times 1/10. But again, that would be really, really silly to write it out that many times. Well, think about what it is when you multiply fractions. When you multiply fractions, you just multiply the top 1 times 1 times 1 times, it's all going to be 1 no matter what. So instead of writing it out that way, I can write 5.29 times 1 over And then how many times are we multiplying 10 on the bottom? We would be doing it 11 times because that's how many times we were dividing by 11. So instead of saying 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10, I'm going to say 1 over 10 to the 11th power. Now it's positive again. I have a positive exponent. Because again, on the bottom, I'd be doing 10 times 10 times 10 times 10, and I would do it some more, right? Times 10 times 10 times 10, all the way 11 times. So this is what you should think of there. So basically what's happening is whenever you divide by 10, you move your decimal point the other direction as we did when we multiplied by 10. So if I did 5.29 divided by 10, that would be 5.29 divided by 10 equals 0.529. Notice that the decimal point is one spot to the left. But I can't divide by 10 just once. I have to divide by 10 11 times in this problem. So 5.29 divided by 10 11 different times, so divided by 10, divided by 10, divided by 10, it's going to move my decimal place a whole bunch of times. And again, we're not going to write the divided by symbol anymore. Instead of saying divided by 10 11 times, I'm just going to say times 1 over 10 to the 11th power. But all this is dividing by 10 11 times. That means I take my decimal point and I move it 11 times this direction. There's 1. Well, what do I do next? I have to do it again, right? 2. That's going to be a space filler 0, right? Well, I only had 1 digit. And I always only have 1 digit in scientific notation. Scientific notation always starts in the front with just 1 digit there. Always. So every time that you do scientific notation and you have a negative exponent, when you move the decimal to make it standard, you're going to move it 1 time and then have to fill in the rest with zeros. So one of the 11 times you move it is going to be onto the other side of your digit. And then I'm going to have to fill in the rest with zeros. That's 10 more zeros. So I know I'm going to have to write 10 zeros. So it's going to be decimal point and then 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Then my 5. And now I can write my 2, 9 in. So I know that I move my decimal point from here 11 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. To get all the way over to here. Now, a lot of people will write the 0 in front of the decimal also to be clear. That doesn't change anything, right? 0 point, 10 zeros, 529. So now we just have to look at this and figure out which one is 10 different zeros after the decimal place. So let's count them up. We'll just start with A here. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. I need 10 zeros. Well, this one I can see is actually shorter, so that's not it. This one I can actually see is too long, so let's look at D and count it up. It makes sense. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. So there it is. Okay, let's do another one. Which shows the expression below simplified? Well, I've got 0.042 plus 1.9 times 10 to the negative 4th. So how can I add those together? Well, when I go to add together scientific notation, I can think of it a lot like adding together our variables when we collect like terms. For example, let's say I have 2 variables. I have 3x's plus 4x's. Well, what is 3x's plus 4x's? You should know that 3x plus 4x, that's 3 times x plus 4 times x, so 3x's plus 4x's, is equal to 7x, 7 times x. How does that apply over here? Well, I have 10 to the negative 4th power right here. And I have 1.9 times 10 to the negative 4th power. So let's imagine for this problem that 10 to the negative 4th power was equal to y, okay, just because I'm using y. Then I could say that 1.9 times 10 to the negative 4th power could be written as 1.9 y. Again, if this is a pretend problem, if 10 to the negative 4th power was equal to y, times 10 to the negative 4th power times y. So this is 2 ways of writing the same thing in this case. If we're just going to replace our 10 to the negative 4th power with y for a moment. Why is that important? Because if I can get this other number that I'm adding over here to be another 10 to the negative fourth power, I could get it to be another y. So how can I turn 0.042 into something where it's times 10 to the negative fourth power? Well, let's remind ourselves. If I want to say times 10 to the negative fourth power, that would be taking my decimal and moving it this way, 1, 2, 3, 4 spaces. So if I need this to be equal to something times 10 to the negative fourth, all I have to do is figure out where would this decimal have come from if I moved it to the left 4 spaces. Just go to the right 4 spaces to figure it out. 1, 2, 3, and then 4 would put a space filler. So it's 420 times 10 to the negative fourth. And in this case, if 10 to the negative fourth is y, we have 420 y. So let's re-explore exactly what's going on here. 0.042. I wanted to make it be times 10 to the negative fourth because my other number was also times 10 to the negative fourth. So I said, hey, I know that if I'm multiplying by 10 to the negative fourth power, I can just move my decimal 4 spaces that direction to the left. So what would I move 4 decimal places to the left and get 0.042? I can figure that out by going backwards and going to the right 4 spaces. When I do that, 1, 2, 3, I'm left to the 42. I got one more space, that would be a 0. So it'd be 420, then the decimal place. And here it is, 420. If I have 420 times 10 to the negative fourth, I could go backwards from 420, 4 decimal places, 1, 2, 3, 4. Get my decimal place there, space filler, and I get my 0.042. I don't need that extra number on the end. It's useless at that point, and that's what we're there with. So basically what I have here, instead of the original problem, which was 0.042 plus our 1.9 times 10 to the negative fourth power, instead of this, I have 0.042 written this way, which is 420 times 10 to the negative fourth power plus 1.9 times 10 to the negative fourth power. And now if you think about these ones as if you were multiplying by anything else, like again, if 10 to the negative fourth power was equal to a variable y, I can think of this as 420 times y, which we just write as 420y, plus 1.9 times y, which is 1.9y. So 420 y's plus 1.9 y's is 421.9 y's. Just like if we added 3x and 4x to 7x, we had 420 and 1.9 to get 421.9. But of course, we're not actually multiplying by y, we're multiplying by 10 to the negative fourth power. So I'm going to write this as 421 times 10 to the negative fourth power. And that's what we're going to write. So is that one of our answers? Absolutely not. And it shouldn't be, because that's not scientific notation. This might be the right value, but it's not scientific notation. I almost messed up. I almost forgot to put it in actual scientific notation. So let's go ahead and put it in scientific notation. Why isn't this scientific notation? We are doing times 10 to an exponent, right? Well, again, scientific notation is always one digit, then a decimal place, then some other digits, and then times 10 to some whatever exponent. Okay, so let's fill this in. The first digit here is a 4, so it's got to be 4. My other digits afterwards are 2 and 1. Well, 4.21 is a lot smaller than 421. So I have to account for that with my exponent. I just made my number 10 times smaller twice. See how I moved the decimal 2 spaces? That's 10 times smaller and 10 times smaller again. That's a total of 100 times smaller. Well, if I need the value of this to be the same as the value of this, I need to make what I'm multiplying by 100 times larger, which means I'm not going to divide by 10 so much. I divided by 10 4 times, right? Because it's times 10 to the negative fourth power. I'm only going to divide by 10 twice. So I'm going to make it -2 right there. And again, let's go ahead and work these two problems and see if they actually come out to be the same thing. 421 times 10 to the negative fourth power. Move the -4. Oh, and I'm sorry, it's actually supposed to be 421.9, right? Forgot about that. So there's a 9 right there, excuse me. 421.9 times 10 to the negative fourth power. Move it 4 spaces, 1, 2, 3, 4. I get 0.04219 times 10 to the negative fourth. What about this one? 4.219 times 10 to the negative second power. Move it 1, 2 spaces. And again, you get 0.04219. So these are equal. It's going to be 4.219 times 10 to the negative second power. Type the correct answer in each box. Use numerals instead of words. Here we go. Christoph bought a new terrarium shaped like a rectangular prism for his pet snake. The terrarium has a length of 1.8 times 10 to the second power centimeters, a width of 1.3 times 10 to the second power centimeters, and a height of 1.1 times 10 to the second power centimeters. Find the volume of the terrarium in scientific notation and in standard form. Answers should not be rounded. The volume of the terrarium written in scientific notation is A times 10 to the B cubic centimeters, where A is something and B is something. So let's go ahead and multiply all those together. If you want to find the volume of a rectangular prism, you multiply the height, the width, and the base. Or height and width and length, if you want to call it. This one has length and width and height. So we're multiplying the length, the width, and the height, all 3 dimensions. So let's go ahead and write down the 3 measurements. 1.8 times 10 to the second power times 1.8 times, excuse me, not 1.8 again, 1.3 times 10 to the second power times 1.1 times 10 to the second power. So I'm multiplying all of these together. So again, I like to think of these a lot of times like they're just variables, because you guys are good at variables and you're multiplying by stuff here, just like you're multiplying by variables. So imagine it was 1.8x times 1.3x. Well, I mean, the decimals might throw you off, but you guys know how to do 3x times like 4x. You would say 3 times 4 is 12. And x times x is x squared, so you would say 12x squared. Well, in this case, we're going to do 1.8 times 1.3. And you guys can use calculators for this. So here we go. 1.8 times 1.3. And you get 2.34. So this times that would be 2.34. And then x times x is x squared. Well, I'm not doing x, I'm doing 10 squared. So it's kind of like saying x squared. What's x squared times x squared? X to the 4th, right? Well, 10 squared times 10 squared is 10 to the 4th. So just these two multiplied together, the first two, all we have to do is 1.8 times 1.3, which is 2.34. And then we have times 10 squared times 10 squared, which is 10 to the 4th. All right, so if you're multiplying scientific notation, all you have to do is multiply the first two numbers, which are kind of like coefficients, and then you multiply your bases, which means you keep the base and you add the exponents. And the base in this case is 10, the exponents are both 2, so add the 2's, you get 4. So 10 times 10 times 10 times 10 is 10 to the 4th. So now I have that, so I've got 2.34 times 10 to the 4th power times 1.1 times 10 squared. So again, multiply the first numbers, 2.34 times 1.1. So I've got my 2.34 times 1.1 equals 2.574. So I've got 2.574 times 10 to the 4th times 10 to the 6th, or excuse me, 10 to the 4th times 10 squared is 10 to the 6th. And we have one digit in our decimal place already, times 10 to an exponent, so that's scientific notation. So let's go ahead and fill this in. A times 10 to the B, A is 2.574, and B is 6. Then all we have to do is multiply that out. We've got 2, and then I got to move it 6 places. So 5, 7, 4, and then 3 more places is 3 space orders of 0. So again, I just had 2.574, and I have to move it, this decimal place, I'm moving it 6 places larger. So 1, 2, 3, 4, 5, 6. So 1, 2, 3 extra decimal places. So 2,574,000. All right, let me know if you have any more questions. This is another subtraction one, just like the other one. Actually, I guess I'll just do this problem really quick. We want both things to say times 10 to the negative 7th power. So how do I turn what I've got there, which is 0.000? How many zeros is that? It's like 5 zeros. Let's count them up. 1, 2, 3, 4. 5 zeros and 8, 4. How do I make that times 10 to the negative 7th? So again, I'm going to take 0.1, 2, 3, 4, 5 zeros and an 8, 4. And I want to make that equal to something times 10 to the negative 7th power. So something that when I multiply it by 10 to the negative 7th power, that's moving the decimal place 7 times to the left. So figure out what it is by moving this 7 times to the right. So we have 1, 2, 3, 4, 5, 6, 7. So the answer is 84 times 10 to the negative 7th. Okay, so again, there's an imaginary decimal right here. It's 84.0. If I do times 10 to the negative 7th, I go 1, 2, 3, 4, 5, 6, 7. So I have 5 space filler zeros, and I get back to what I had right here. There's 5 space filler zeros. So why did I want it to be 10 to the negative 7th? Because this was 10 to the negative 7th, and I can only subtract stuff if they're both times 10 to the same exponent. So now I have 84 times 10 to the negative 7th minus 4 times 10 to the negative 7th. And here we go. It's 84 minus 4, 80. So I have 80 times 10 to the negative 7th. But this is not scientific notation. Remember, scientific notation is a single decimal and then a decimal point, or so a single digit, I should say, and then a decimal point. This 80 is 2 digits and then the imaginary decimal point. So I have to turn 80 into 8.0. I just made this 10 times smaller. I moved it 1 decimal place, so it's 10 times smaller. That means my exponent, I have to make it so that when I'm multiplying by, it's 10 times bigger. So I'm going to say times 10 to the just negative 6th now. So you're always adding to this exponent if you want to make it 10 times bigger. Every 1 that you add makes it another 10 times bigger. So negative 7 plus 1 is negative 6. So 8.0 times 10 to the negative 6th power. Or we could just say 8 times 10 to the negative 6th power. And that's it. All right, if you have any more questions, let me know. And I will help you as much as I can. If you have a specific problem, email me and tell me what the topic is, like scientific notation. I'll go look at the last problem that you were working on.